Hi, welcome to Calculus Quest, the channel where you can find or brush up on your mathematical skills with many different math problems. So remember to grab a pencil, be ready to sharpen your mind, and let's tackle a few derivatives on today's lesson. Thus, our first problem is f of x equals 2 to the 40. So let's find the derivative of 2 to the 40. What is derivative? So first of all, we don't have a variable here. We have a constant. That's one thing we have to understand. What is the derivative of a constant at that point then? What does that mean? Well, the derivative of a constant is always 0. But why? Well, it's a rule within calculus indicating that if you have a variable, then a variable you can take a derivative of. However, if you have a constant is always 0. Thus, the rule indicates that d dx of c, constant, equals 0. So d dx of 2 to the 40th equals 0. We'll go on to the next problem. Hopefully this is able to explain it a little bit easier. So, problem number 2, f of x equals e to the 5th. So e to the 5th is e to the 5th a variable or a constant? Well, e to the 5th is a constant. So d dx of e to the 5th, if you recall, using the constant, that is because it's a constant, we know that d dx of a constant, or c, is 0. So d dx of e to the 5th is 0. We'll go on to more problems, and as we keep going, they'll become a little harder. So problem number 3, we have f of x equals 5.2x plus 2.3. So here we have something a little bit different. We no longer have a constant alone in our function, but we have also one variable. So let's try to take the derivative of our variable. So d dx equals 5.2x plus 2.3. So what is the derivative? As once again, we'll say we have one variable, so that is 5.2x, and one constant, 2.3. What does that mean? We know the derivative of a constant is 0, but the derivative of a variable, such as x, alone, would be 1. So d dx of 5.2x plus 2.3 equals 5.2 plus 0. Then we get 5.2 if we simplify. So we'll go on to problem number 4. For problem number 4, we have something similar to the previous problem of number 3. Let's see if we can do this one again together easily. So our function is f of x equals 25x plus e to the 50th plus 20. So here we have a couple things that are similar to the previous problem. I'll give you a few seconds to solve this one on your own. You can stop the video and solve it on your own. I'll finish the problem now. So we take the derivative, so 25x plus e to the 50th plus 20. So we know that e to the 50 is a constant and 20 is also a constant. The only variable here is 25x. Thus, we take the derivative of 25x, we get 25 plus 0 from e to the 50th plus 0 from 20, which is another constant. Thus, when we simplify, our value is 25. We'll go on to number 5, problem number 5. So here we skipped the function itself and we went straight on to taking the derivative. So we have d dx of 7 over 4 of x squared minus 3x plus 12. What does that equal? Well, we're trying to find the derivative. What is the derivative? Well, we have two variables, which are 7 over 4x squared and 3x minus 3x. And one constant, which is 12. What does that mean? Well, that means that we'll have 1 0 within within our final solution, and two and two numbers that will stay alone. However, we know the derivative of a constant is 0, but the derivative of such as x is 1. But what about the derivative of a power of something such as x squared? I'm not sure we've encountered this before, but we'll solve this. For a variable to a power, we can use what is known as the power rule. We'll talk in more details about the power rule in following problems or following videos. But we'll simply just write it here, and ddx x to the n equals nx to the n minus 1. Well, this basically just means that whatever power that you have, such as x to the n, when you take the derivative of it, you place the n in front of the x, and then you subtract 1 of this power. So in our case, what we basically do, we move our 2 to the front, so we multiply that by 7 over 4, and then x it will be squared, so we subtract 1 minus that 2, so it just becomes 1. So x to the first is just x, and then for the second, it's just 3x. The derivative of 3x of negative 3x is just negative 3. Thus, we get, for our value, we have 14 over 4x minus 3. That is the final answer. Well, we have 12, and the derivative of 12 was 0, so basically that's why I didn't mention it. It was a constant. I figure you're keeping along with me. So we'll go on to the next one. So problem number 6. So problem number 6 is a little different. We have h of u equals 3u minus 1 and u plus 2. How do we take the derivative of a non-distributed binomial? So we have to multiply the binomial using the FOIL method. I don't know if you recall the FOIL method. It just is a distribution method for distributing binomials into something simpler to actually use for such as a exponential function. Is what we will get here. We'll get a quadratic. So we have 3u minus 1 multiplied by u plus 2. So when we multiply using the FOIL method, we multiply 3u times 3, so we get 3u squared. Then we multiply 3u times 2, so we get 6 plus 6u. And then we'll multiply minus 1 times u, so we get minus u. And then we multiply minus 1 multiplied by 2, so we get minus 2. So we have 3u squared plus 6u minus 3 minus 2. So we simplify. By simplifying, we get 3u squared plus 5u minus 2. Now we can take the derivative. So taking the derivative, we have ddx of 3u squared plus 5u minus 2. So as we've used in previous problems, we use the power rule. Using the power rule, we move the 2 forward, so we get 2 times 3 u, and so we also, and then we subtract 2. We take 1 from 2, so we get 6u plus 5, because the derivative of 5u is just 5, and the derivative of negative 2 is just 0 because it's a constant. So our final answer is 6u plus 5. So we're going to the next problem. Hopefully this one is a little easier. In my opinion, I think it's a little easier. So this is problem number 7, and we have f of r equals 5 over r cubed. Well, okay, it is a little different than we've seen in previous problems. So what is the derivative? First, we rewrite the function f of r equals 5r to the negative 3. That way we can actually apply the power rule. This becomes a little simpler for us. So we know the power rule from our previous problem. But first, let's write it in the form of, in order to take derivative of the function, f of r equals f of r of 5 over r cubed. So the derivative equals d dx of, well, it's not d dx, it's d dr. Because if you do d dx, it wouldn't apply. So we do d dr of 5r minus cubed, well, to the negative 3. So d dr of 5r to the negative 3. We take the derivative and we get negative 15 r to the negative 4. Using the power rule, as we studied in the previous problem, is d dx of x to the n equals nx to the n minus 1, moving the power in the front, and then we subtract the power minus 1, and then we get our final answer from there. Our final answer for this problem is negative 15 r to the negative 4. I hope that helps. So we'll go to the last problem, problem number 8. Problem number 8 is a little different. We have the square root of something. So we have s of p equals the square root of p minus p. Simplify the function s of p equals square root of p minus p. So we'll simplify in order to take the derivative, which makes it a little easier for us to take the derivative. So in order to take the derivative, we know that the square root of p can also be written as p to the 1 over to the power of 1 over 2 minus p. So now we take the derivative of d dp of p to the power of 1 over 2 minus p. Taking the derivative, we use the power rule as previously used in our previous problem, number 7, and we have 1 over 2 p to the power of negative 1 over 2 minus 1. We simplify, and we end up having 1 over 2 square root of p minus 1. I hope that was easy to understand. Please let me know in the comments if there's any questions regarding these problems or any other math problems that I could assist with. I hope you had a good time. Enjoy the math problems. Have a good day.